Year 10 Indices, Fractional Indices. So we're going to think about what it means when we have an index that is a fraction. So my question that we're going to try and answer this lesson is, what does 10 to the power of a half mean, as an example? And what about other fractional indices as well? What do they actually mean? How do they work? How do you calculate a fractional index? So, as always, we're going to start with some examples to illustrate this. The first example that I'm going to start off with is 64 raised to the power of a half. And we're going to try and work that out. Now, I'm going to start off by rewriting 64 as 8 squared. So you can see that red 8 squared corresponds to 64, and afterwards it's got to be raised to the power of a half. But you know there is a rule for indices that you have seen. If you have x to the a and it's all raised then to the b, you multiply the indices, so it's x to the a b. And we can do that here. We can multiply the indices. So this gives us 8 to the power of, and we're multiplying 2 by a half, which gives us 1. So the answer to 64 to the power of a half is equal to 8, because 8 to the power of 1 is just 8. So that's quite interesting. Let's try another example to see if we can start to build up a pattern. 16 to the power of a half. Now, I'm going to do something similar to last time. Instead of 16, I'm going to write that as 4 squared. This all has to be raised to the power of a half, and I have the situation again where I have a power of a power. I need to multiply the indices, and that gives me 4 to the power of 1, because 2 multiplied by a half is 1. So I now know that 16 to the power of a half equals 4. And we start to build up some results, and you might start to have in your head the idea of a pattern. Let's do one more example. 100 raised to the power of a half. Some of you may have guessed the answer already. So instead of 100, what should I write? Instead of 100, I'm going to write 10 squared, because that's an equivalent way of writing 100. So again, we have power of a power. We need to multiply these indices together. So this gives me 10 raised to a power of 1, or just 10. So I have another result, which is that 100 to the power of a half is equal to 10. So let's look at these results. 64 to the power of a half is 8. 16 to the power of a half is 4. And 100 to the power of a half is 10. Do you recognise what's happening here? So you may have realised that if you raise a number to an index of a half, this calculates the square root of that number. So we know, for instance, that the square root of 64 is 8, because 8 multiplied by 8 is 64. The square root of 16 is 4. The square root of 100 is 10. So a power half means find the square root of a number. So the next logical question to ask ourselves is, what about other fractional powers? What about x to the power of a third? What does that actually mean? So we're going to illustrate this with an example again. We're going to look at 27 to the power of a third. Now, I'm going to rewrite 27, and I'm going to remember that 27 is the same as 3 cubed. Remember that? 3 multiplied by 3 makes 27. So I'm replacing the 27 with 3 cubed. Using the law here, again, where we multiply our indices, gives me 3 to the power of 1. So 27 to the third is 3 to the power of 1. So again, some of you may have started to realise what a power third actually calculates. But let's illustrate it with another example. We're going to work out 8 to the power of a third. So I'll rewrite 8 as 2 cubed, and then an index raised to another index, multiply these together. This gives me an answer of 2 to the power 1. So I can see that 8 to the power of a third is equal to 2. So again, you may already know what's going on. Let's do one last example to confirm this, hopefully. 1,000 raised to the power of a third. So how else can we write 1,000? Well, 1,000 is the same as 10 cubed, 10 multiplied by 10 multiplied by 10. Let's look at the overall index here. We need to multiply our indices, and this will give us an answer of 10 raised to the power 1. So this gives 1,000 to the power of a third equals 10. So have you worked out the rule? Can you see that if you raise a number to the power of a third, it calculates the cube root of that number? Because the cube root of 27 is 3. The cube root of 8 is 2, and the cube root of 1,000 is 10. Now, just in case anybody's not sure about what we're asking when we calculate the cube root, well, the cube root of 27 is 3 because the question is which number multiplied by itself 3 times, i.e. which number cubed is 27, and the answer is 3. So that's what a cube root is. So can we write down some rules? Well, we can certainly say that x to the power of a half means square root of x. X to the power of a third means cube root of x. And we can generalise to say x to the power of 1 over n is the nth root of x. And we'll have a look at some examples to illustrate this in a moment. So have a go at these examples as we go along. First one, 36 raised to the power of a half. Well, that means the square root of 36, which is 6. Number 2, 49 to the power of a half. That means the square root of 49, which is, of course, 7. Now, a little trickier, 64 to the power of a third. The cube root of 64. So which number multiplied by itself again gives us an answer of 64. That's what the question is, and of course the answer is 4. 4 multiplied by 4 is 16, multiplied by 4 again is 64. So it's the cube root of 64. Number 4. What about 81 to the power of a quarter? Now that means the fourth root of 81. So we're asking ourselves what number multiplied by itself again, multiplied by itself one more time, gives us an answer of 81. And the answer to that question is 3. 3 multiplied by 3 is 9, multiplied by 3 again is 27, multiplied by 3 a fourth time is 81. So the fourth root of 81 is indeed 3. So, next question, number 5, over here. 32 to the power of a fifth. So the fifth root of 32, what number multiplied by itself 5 times overall gives you an answer of 32? See if you can work it out. The answer is in fact 2. Question 6. 1 to the power of 1/8. Now that's easy. The 8th root of 1 is going to be 1. So 1 raised to any power will always give you 1 as an answer. Now, number 7, 64 to the power of 1/6. The 6th root of 64. Can you work it out? Which number multiplied by itself 6 times gives you 64? The answer is 2. Now, 2 slightly trickier questions coming up. 20 to the power of 1/2. Well, of course, this means the square root of 20. Now, you can simplify this using your knowledge of surds. This is root 4 multiplied by root 5, so it could be simplified down to 2 root 5. And question 9, can we do something similar if we were asked to work out 48 to the power of 1/2? Well, again, we know it's root 48, so that is root 16 multiplied by root 3 in surd form, which is 4 root 3. Now, a lesson would never be complete without looking at a couple of trickier examples. So I think if we're still counting from the previous page, we are up to question 10. So we're going to work out 1/4 raised to the power of 1/2, which means what is the square root of 1/4? Now we can square root the numerator, take the square root of the denominator. The square root of 1 is 1, the square root of 4 is 2, so the answer is 1/2. Think about every step of that very carefully. Perhaps try the next question. We're going to raise 4/25 to the power of 1/2, which means that we're going to square root 4/25, and again, we can take the square root of the numerator, the square root of the denominator separately, which is 2/5 as a final answer. So we're going to finish off with a very quick final summary of the rules that we have seen so far involving indices. Number 1, x to the a multiplied by x to the b. Fill it in. What do you get? X to the a plus b. Number 2, x to the a divided by x to the b equals x to the a subtract b. Number 3, x to the a all raised to the power b, x to the a b. So the first 3 rules that we looked at. We then reminded ourselves that x to the 0 is simply equal to 1. X to the 1 is equal to x. We then learned about negative indices. So x to the negative n is 1 over x to the power n, the reciprocal. And to finish off with, we've learnt about fractional indices. So we know x to the 1/2 is the square root of x to the power of 1/3 is the cube root of x, and in general, x to the power of 1 over n is the nth root of the value of x. Now, in a minute, you're going to test your knowledge on a little true or false quiz coming up. So here you have 10 statements. Looking at each one, decide whether or not they are true or false. If they're false, can you correct them and write the correct answer, and perhaps explain where somebody may have got the wrong answer from, i.e. what is the misconception behind this. Make sure you pause the video and have a go at the 10 questions before you go through the answers. So let's check these. Now the first one, x cubed multiplied by x to the 4 is not x to the power 12. The answer is x to the power 7. Somebody has tried to multiply the indices instead of adding them. Number 2, false. The answer should be x to the power 6. Somebody has tried to divide the indices instead of subtracting. Number 3, false on 2 counts. It should be 8x to the power 6. So somebody has forgotten that the 2 has also got to be raised to the power 3 because you are actually working out 2x squared multiplied by 2x squared multiplied by 2x squared. And you should be multiplying the indices here to get 6, not adding them to get 5. Question 4, also false here, incorrect. You cannot work out a calculation like this because the bases are different. And even then, somebody's tried to multiply the indices together instead of adding them, although it would certainly be very wrong in this question because the bases are different. All you can do in this question is evaluate each term, so that's 9 here from 3 squared, and then 2 to the power of 5 is 32, and then you could work out what 9 multiplied by 32 is. And that is an answer of 288, and that is not the same as 6 to the power 10, which is a much bigger number. Question 5, also incorrect. 4 to the power of negative 2 is 1/16, the reciprocal, not negative 16. Somebody has tried to multiply 4 by negative 2 here, which is a totally different question. Question 6, also wrong. 5 to the power of 0 is equal to 1. Question 7, also wrong. The answer to this should be 2x squared. To get an answer of x to the power 4, you would have to work out x squared multiplied by x squared. Question 8, also wrong. Somebody has tried to square the 2 and then do something with the indices. The answer to this question should simply be 2 raised to an index of 6 here. Think about what you're doing. You're doing 2 cubed multiplied by 2 cubed, add the indices to get 2 to the 6. Question 9, also wrong. Somebody has tried to work out half of 16. That's not correct. 16 to the power of a half means the square root of 16, which is equal to 4. And the very last one, question 10, also false. 3 to the negative 1 means 1 over 3, the reciprocal, not multiply 3 by negative 1. So if you answered false to every single one of these, you were absolutely correct. But did you understand where the errors may have come from? Go back and look through these explanations again if you need to.